Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Srimati Kumaran Institute of Technology. Today we have learned the subject on MR3452 Control Systems Engineering for 2021 regulations. In this presentation, we have to discuss the transient and steady state behavior of second order control systems and their performance characteristics. Introduction. A control system is represented a second order system is represented by a second order differential equations. Such systems are widely used in engineering because they accurately describe many practical systems. So the response depends mainly on damping ratio psi and natural frequency omega m. Standard form of second order system presents the standard transfer function g of s equal to omega n square divided by s square plus 2 sin omega n s plus omega n square. So it explains the significance of natural frequency and damping ratio. Types of damping. So it discusses the different types of damping conditions. Underdamped, for underdamped, psi less than 1. For critically damped, the damping ratio psi equal to 1. For overdamped, damping ratio psi greater than 1. For underdamped, psi equal to 0. It explains how damping affects the system responses. So for critically damped, the roots are purely imaginary and this is purely imaginary. For critical system, the roots are real and equal. For undamped system, the roots are purely imaginary. For overdamped system, roots are real and unequal. These parameters help evaluate the system performance. Then time domain specifications. So introduce key performance parameters: delay time, rise time, peak time, maximum overshoot, settling time. So rise time. These parameters help to evaluate the system performance. So rise time. So rise time is the time required for the response to rise from 10% to 90% of the final value. So it indicates how quickly the system responds. So TR is equal to pi minus theta divided by omega t. Peak time. So peak time denoted as TP. So it is the time required to reach the first maximum peak. It shows how fast the system reaches its highest overshoot. Then maximum overshooting. So maximum overshoot is the amount by which the response exceeds the final value. It is usually expressed as a percentage. Highly overshoot indicates lower damping. So percentage of m is equal to e power minus psi pi divided by root of 1 minus I square into 100. Then settling time. Settling time is the time taken for the response to remain within the specified error band, usually plus or minus 2% or plus or minus 5%. It indicates when the system becomes stable. So for settling time, t is equal to for 4 divided by sin omega n for 2% error, t is equal to 3 divided by sin omega s for 5% error. Then we have to see one example problem for time response of second order systems. In the response of unity feedback system, whose one open loop transfer function is g of s equal to 4 divided by s into x plus 5, and when the input is unit step. So now we have to find the closed loop transfer function c of s divided by r of s equal to g of s divided by 1 plus g of s. Then we have to given that the input r of s is equal to 1 by s. So we have to substitute the response in the s domain. C of s equal to r of s into 1 by s into 4 divided by 4 s into x plus 1 to into x plus 1. So here in numerator we have 3 terms. So we have by applying the partial fraction expansion, we can write we introduce the 3 variables for 3 terms. So a divided by s plus a divided by b divided by s plus 1 plus c divided by s plus 1. So then we have to find the residues A, B, C. Then and the time response C of t is obtained by taking inverse Laplace transform of C of s. So C of s equal to 1 minus 1 by 3, 4 e power minus t minus 4 e power minus 1. So the response of unity feedback system C of t is equal to 1 minus 1 by 3 into 4 e power minus t minus e power minus 4t. Then anyway, this is another one example for the response of the time domain analysis. So a positional control system with velocity feedback is shown in figure. What is the response of the system for unit step? So same resolution. Thus we have to write the closed loop transfer function c of s divided by r of s equal to g of s divided by 1 plus g of s h of s. Then we are given g of s equal to 100 over s into s plus 2. Then we know that h of s equal to 0.1 s plus 1. So we have to find the response of the system in S domain. We have a BC of S equal to. So here by applying the partial functions, we have to find the residues A, B, C. Then we then we have to find the time response is obtained by taking the inverse Laplace transform. Then we have to find C of t is equal to 1 minus e power minus 80 e power minus 80 6 by 8 into sin 80 plus cos 8. This is the response of the system. Advantages of second order system. So, realistic modeling of practical systems, simple yet powerful, captures important dynamic behavior, and it's useful for performance analysis and controller design, and it provides standard design parameters. Then application of second order system is used in mechanical system, electrical system, industrial control systems, electromechanical system, and aerospace and robotic applications. And these are the reference for this presentation. Thank you.